Greetings. Today we will present our presentation, which is auto clutch housing and shoe. My name is Alvivira Johnson, along with Muhammad Mil Iqbal bin Ismail. We'll start. Now, let's start with Newton's first law, also known as the law of inertia. This law tells us that an object will stay at rest or keep moving at a constant speed and a straight line, unless acted upon by an external force. Inertia is simply an object's resistance to changing its motion. Now, how does this connect to centrifugal force? Imagine an auto-clutch system. At low rotational speeds, inertia keeps the clutch shoe from moving outward. But as the rotational speed increases, centrifugal force becomes stronger. Once this force is strong enough to overcome inertia, the clutch shoe moves outward and engages with the housing. Pretty neat, right? This combination of forces makes the auto-clutches work efficiently. Now, let's talk about the auto-clutch system, specifically the clutch shoe and the clutch housing. First, let's look at the clutch shoe. It is an essential component of the system. The springs attached to the clutch shoe play a key role. They keep the clutch shoe retracted or pull it inward when the clutch engine is running at low RPM. This prevents any unintended contact with the clutch housing, which helps avoid unnecessary power transfer. Next, we have the clutch housing. The housing surrounds the clutch shoe and only becomes active when the clutch shoe moves outward due to the increase of RPM. At this point, the clutch shoe makes contact with the housing's inner surface, allowing power to transfer efficiently. In simple terms, the springs manage when the clutch shoe engages, and the housing is where this engagement happens to transfer power. Together, this component ensures smooth and controlled operation in auto-clutch system. Thank you. At low RPM, the clutch shoe doesn't touch the housing because centrifugal force is too weak to overcome the inertia. According to Newton's first law, the shoe stays stationary unless acted on by a strong enough force. The housing rotates, but without contact, no power is transferred. In simple terms, the clutch stays disengaged at low speeds.
Okay, next, at high RPM, contact and rotation begins, where the key concept in this situation is transition from inertia to motion. Initially, the shoe is at rest and resists motion due to inertia. Then at high RPM, the centrifugal force overcomes the shoe's inertia. And at high RPM, the centrifugal force causes the shoe to move outward and make contact with the housing. Then the friction between shoe and housing transfers rotational motion. Next, the mechanical insight is the shoe engages the housing, enable it to rotate. Then rapid changes in RPM require overcoming the shoe's inertia resistant to movement. Inertia. Next is sudden low RPM. The key concept in this situation is momentum and gradual deceleration. So, in this situation, the housing is already in motion. It continuously to rotate due to its inertia. The shoe then loses contact with the housing as its centrifugal force decreases. In this condition, the shoe retracts inward due to the spring tension or gravity. Then, the housing slows down gradually because no active force maintains in rotation. And mechanical insight in this situation is the system illustrates Newton's first law, where the housing continues moving until friction or other force, external force, to slow it down. Next, energy dissipation occurs as heat and sound during deceleration. Okay, this is the last part. Come on. So, that is all from us. Thank you.